Getting live, and now we are live. All right, guys. So I think probably the first thing we should do is like talk about the buffer part, because I think that probably is faster, I guess, than the other one.
What is the other one?
The other one is the discussion we had on GitHub regarding the PR that Stephen Tope submitted with all the exception changes.
Yeah,
Which should be on what we want to write down, because I think our guidance right now is almost 100% the opposite. Right, so for the buffers thing, there was a bunch of concerns about how we deal with buffer management, right? So we have this thing called system.buffers, which I think lived in CoreFX lab for a while, right? And then you moved it over, like, what, 2 months ago, something like this, right?
Something like that, yeah.
And then now we started using this across CoreFX. And Jan, you had some concerns about what that would mean for safety. Can you summarize what the concerns were?
So basically the problem is that if you have a class, say file stream, right, that's using buffer internally, then if the people who are using the file stream, and if you use the buffers in the file, if you basically just replace the array of the internal kind of buffer allocation inside file stream with call to buffer alloc, and in this post method you kind of just return it to the buffer pool, right? That works great, but if people who are using the file stream have a bug in their code, like threading bug in their code, that they are calling methods on multiple threads in parallel, what it might happen is that the dispose method runs because they call dispose method on one thread, but other thread is still reading from that buffer or writing to that buffer, and what can happen then is that that buffer gets checked out by somebody else, and now you have data corruption that is like impossible to trace down, right?
So the problem is not so much that we have bug in our code. The problem is that the consumers have bug in their code using our library, which then in turn causes the ripple.
Well, it's not even clear whether we can actually have bugs in our code.
Yeah, we can. That's true. Right?
Or not bugs. I would say like it's unclear whether some of these conditions are even bugs, because today you can use file stream in a way it works, and there are actually no problems with it. Suddenly, when we switch to a buffer, you have exactly the same code.
And
you probably are using it slightly incorrectly, like you're not using it how we prescribed, but it does work today, and then in the future it would break. So that's,
the key value we had in .NET since the day one. Originally it was driven by the fact that we were trying to target, the partial trust environments and such. It kind of forced it. But the key value is that it's not possible, assuming you are using SafeCode, it's not possible to cause global data corruption. So if you have a bug in your code, let's say, for threading bugs, if you are using dictionary in not thread way, you can get the dictionary into messed up state, and you can get exception coming out of dictionary that says, hey, like this is like messed up, but you cannot introduce like corruption in like some in completely independent thing by using dictionary incorrectly, right?
To me, like, I mean, if we have bugs in our code that stuff doesn't work, and maybe even if it's impactful, that's bad. I think to me the problem is, though, if it's bugs in consumer code, it's orders of magnitude worse.
But I think there are actually 3 levels, and we had an email exchange, and I said I'm in the middle. One level is we basically can guarantee that you never have problems with BufferPool. Literally never. You cannot screw up. And I think the bar is too high. It would mean you would literally, like, we cannot use BufferPool. Then there is I would say low bar, which is if your code is correct and our code is correct and you follow all the rules, that you're going to be fine. Otherwise, you may run into a problem. And then I think there is like one in the middle, which is where I think we should be. If you don't use BufferPool yourself, I think there should be no change for you from a perspective how .NET worked in the past. There's no global data corruption because you're not using BufferPool, correct? You're just using file streams, and maybe we use it internally, but we ensure that no matter how you use file stream, you may not using the prescribed guidance.
So,
But how
the difficulty? Sorry, the difficulty with that middle one is pretty much every useful usage of BufferPool we could have in CoreFX would violate that middle one. Because, for example, even probably the most trivial one, which is copy to async, we get a buffer, we call read write, read write, read write, we release the buffer, but we're handing that buffer out to some arbitrary stream underneath us, which could hold on to that buffer and do something with it long term. So even in that case, we can't guarantee that the buffer isn't being used. Same with deflate stream wrapping another stream. Pretty much every case it falls into that category.
I'm not sure if I understand why handing the buffer to another stream is a problem.
Because they can hold on to it.
So,
like if you have malicious stream, right?
yes.
Then if you have malicious stream that that holds on the buffer, or it doesn't need to be malicious. It can be just plain buggy, right? Like you have a stream, it has buggy implementation of async that kind of returns, but it still keeps writing to the buffer.
No, but that's fine. So I didn't even finish what my middle ground is, because to me it's like, as I started to say, I'm just using components implemented by the .NET team. We can assume that they don't have bugs, and I'm using some other components that don't have bugs. I should be completely safe, because I'm a user who's not even aware that buffer pools exist.
No, you have a bug.
Let me finish the bar, and we can discuss. The moment you use the buffer pool directly, like you in your code started to now using buffer pool, or you pull in a component that has bugs, or we have bugs in the .NET framework, I think then, well, it's fine. At that point, it's not ideal, but I think that's a reasonable bar to have.
So hang on. In this case, the bug would be in a component that may never have heard of BufferPool, but just used an array that was passed to it incorrectly. And I think the main thing here is that, this is a fundamental, I think this is the thing we have to think about, is fundamentally different behavior for the platform, where a bug, I mean, it's a key value proposition of the platform historically, that bugs, like this, don't just manifest themselves in some very arbitrary way later on. Like the fact whether the bug is on our side, on their side, whether they use BufferPool or not, I think it is extremely interesting to think about the fact that this bug could exist in some derived stream class, and then with no knowledge of what a BufferPool is, and the manifestation of that bug could be really, 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 really hard to actually track down.
Right, and that's kind of like if you talk to people like Mark Rusinovich, right? Mark Rusinovich is saying, I don't say it exactly, but basically like his point is like, hey, when people are writing Azure Web Services, like I don't know how they can write them in C++, right? That he's saying like the only way to write a web service for Azure that actually works and doesn't have like data corruptions and stuff, right, is to use C# because of these guarantees, right?
Well, so I understand that, but my position is that over time we should get our components to be hardened and treat and return buffer pools correctly. Mm-hmm. Therefore, some of the issues that maybe we have today that Steve was talking about, like today when there's an async operation in the flag.
Yeah, but the problem is like we are calling back into code that we don't know.
So that one is yet another one. I think that today we don't have facilities to give people access to the buffer pool. Like if it's all internal, I think we can harden. The moment there are APIs where you give pools to third-party code, mm-hmm. We don't have a way to prevent today from people doing the wrong thing. I think longer term we should hand buffer to third-party code only when they are wrapped in spans, if we can get spans to be stack only.
Yeah.
And then they can just use the buffer. They cannot do anything with it, even return it to the pool. Yeah. And I think if we end up in this situation, I think it's reasonable bar. Basically, we would work over time to get those bugs out of our code, our component, harden them, hand the buffers to third-party code only through spans, And I understand that it's not as resilient to problems as without using a buffer pool, but I think it's a reasonable bar. That's just like, I was trying to explain where my bar is of where
So
I feel.
if that's the bar we adopt, which might be a fine thing, I just want to point out that we basically won't be using BufferPool anywhere in CoreFX because there's like one or two minor
right. So I think you can still say, I think the interesting case is like the case of file stream, right? Whether it will be worth it to use it for the internal buffer of the file stream and pay the cost of checking it in and out for every operation.
Yeah. So I'm not sure if I use. Steve, you keep saying that we wouldn't use it almost anywhere. I think we wouldn't use it for the copy operation that you described, but the file stream compression stream usage, I think.
No, we can't use it in deflate stream either because we hand it wraps another stream.
File stream doesn't wrap another stream.
No, deflate stream. Sorry, he said for compression.
Okay.
It wraps other stream, and we use the buffer, and we pass the buffer to the other stream.
Right, because you compress data into the buffer, and then you give that buffer to write to another stream.
So one thing we could discuss is, maybe we can expand it. We say user that doesn't implement, framework abstractions, just uses components that are available in CoreFX and should be safe. The moment they use a custom implementation of a stream that is buggy, then maybe we are okay with it. I don't know. That could be worth discussing.
So one thing I didn't quite get is you just said that if we would move to span of t, that would help a bit because it's stack only. That part I don't quite understand. Why would that help you?
You cannot return. Basically, you're getting span of bytes. Well, you cannot return it to the buffer pool.
You cannot hold it in the backend.
Hold it for
the stack local nature doesn't allow me to stash it away or I see.
In SafeCode, we still have to solve the problem of you must be able to stash spans on the heap, but then we said in the past that we would just do it in an unsafe context.
Yeah. I see. So okay, makes sense. So then. So, to understand your bar, for example, if you have static APIs, file read all text or whatever, those internally could use buffer pooling because there's no way the user code can interfere with this, right?
To very high level, to summarize, my bar is, I'm a user, I'm using components that don't have bugs, I don't use buffer pool, I should be fine. The moment I'm either implementing, custom component streams or whatnot, or I have bugs in my code, or I'm using components that have bugs, well, you have bugs in the code,
I just think that the main question is well, you have bugs is one thing, but I think the diagnosability of bugs, it's not so much the guarantee of what happens as a sort of a security thing or anything, but as much as just the debugging of a situation like this is going to be extremely painful, when it happens. And that's something that I think that probably and it can be sort of you mix and match NuGet packages across the ecosystem, and one thing does something strange, and then it's really hard to know which thing did this and how this happened. And
I agree with you. The thing is that people can create and do create, and there are reusable buffer pools out there anyway.
They're more on the higher layer, right? So the lower you get, the more interactions you have, right? If it's really literally in string and you have a bug there, that easily goes everywhere. Right?
No, I agree with that, but also there is a different force, which is the lower it is, and if it's in our code, we should be able to get rid of the bugs, correct?
No, but in Jan's example, right? If it's let's say a stream, right, which is pretty low. The problem is you implement your own type, so the user code or the third-party code interferes with that lower layer, right? So that even if we get it right, if you get it wrong by deriving from that thing still goes potentially everywhere depending on what.
Correct. But I would say, how many people implement streams, and if it's something that customers use very often, over time it should get,
it's kind of, about kind of the guarantee side. Today, when there is like junior developer writing Azure Web Service, if he's using SafeCode, he cannot screw up the rest of the system, right? It's like if it will fail like with his stuff on the stack, and we will route the bug to him, and we are done, right? And now we are saying, okay, we need to also watch for like those junior folks implementing streams, right?
Yeah, I don't agree. Yeah. So they can implement their own pool. They can do exactly what we are doing, and then they.
Yeah, but it will be still in their code, right? If the guy decides, okay, I'm smart.
Not in the code. If they pass the buffer pools to custom streams like we are just talking about, it will not be just in their code. It will be in anybody's code that uses those streams.
No, it will be still in their code.
Well, it depends on how you do it, right? But like, let's say I write a buffer pool. This is on top. My stream abstraction is using it, and then there's another system built on top of me that basically uses my streams. Well, then the code that actually may have the bug is actually in that higher level component, right? And then if that blows up, then the guy who wrote the buffer pool or that wrote the underlying stream may not be on the stack at that point, right? So, but I agree with you. Like in principle, I like the idea of localized errors, which is a huge thing. But like, I mean, in the past we have done something very similar with multi-threading and UI controls, right? At some point we said, well, you shouldn't use this for multiple threads. Turns out people do it all the time, and sadly it works in enough cases that people don't find it actually. Mm-hmm. And then we started to throw exceptions when they do this kind of thing, when they run with the what's it called, the MDAs being enabled or whatever, right? Could we do something similar here? Or do we think that in practice you will never be able to find those?
So one thing we could do, but it just complicates the feature. We had this idea of, instead of giving people arrays, we give them a small struct that is called buffer. And then in this struct we can track more, like,
ownership essentially.
So then we can give you better diagnostics. Like we could play with it a bit, but it's like it doesn't completely solve the problem.
Yeah.
And it introduces some other complexity in APIs. Now we have to have like sockets that takes this, not array, but takes this buffer thingy. We are back to the legs, span-like problems. So I don't know.
I think like the diagnostics for this basic would have to be going in the same direction as what Diagnostics looks for malloc-free today, right?
Which means it's compiled out most of the time. Because you're not running under the debugger, you're not running with these things enabled in practice.
What's the contract for use after? It's like, because we're talking about really the flushing, like for instance, a flush after dispose call, right? So, which is how you cause the globalized corruption. What's our contract today for use after dispose? Is that undefined behavior? Like, what's our definition for using an object after dispose has been called?
The object is supposed to throw in cases that it's legal.
Yeah. Well, it either works or throws object dispose exception.
Yeah.
That's
do we define one, or is it technically undefined behavior?
Like it's like undefined. We do best effort, right?
Right.
So if you are calling read on a stream on one thread and dispose on another thread, it will work most of the time. Sometimes you can get an exception.
Right. So right now they still have the same problem where sometimes it'll work and sometimes it won't. Which right now it seems like.
Well, it doesn't necessarily. Like if you are careful, like for the case of stream, one thing calling read, other thing calling close.
Right.
If you are guaranteed that the close is called after you kind of start the read, then
I think the difference is that today, let's say you did something like what you described with a stream, like you're doing some async operation, you're disposing on a different thread.
Right.
Your stream, the operations that your stream is doing are gonna be screwed up potentially. With the buffer pool, if you do something wrong with async and dispose, some other stream in a completely different parts of the system may be screwed up.
Right.
That is the new thing.
And the worst case is that it doesn't throw an exception, it just reads corrupted data. Like, I mean, like the nice thing, when we have races with dispose usually, you get usually pretty simple error messages. Like if I dispose secret connection while I'm reading somewhere else, well, suddenly the connection is terminated, right? The problem with buffers is when you have races when they return and read, you get arbitrary results. In many cases, you may not even throw an exception. You just
arbitrary results. Because during, at least in all the use cases that Steve and I have done, when when you implement the stream, you actually set once you return it, you set it to null. So the read or write would not actually happen because you have a null object, so there's nothing you can do to corrupt the state. You've returned it back to the stream, you have null.
Yeah, but there might be operation in progress while you are setting it in null. That's kind of the...
You're setting your variable to null, while some other variable already points to this buffer because it's doing async and it's stashed it.
Fair. What precedents do we have today for like preventing users from shooting themselves in the foot in terms of like doing blatantly incorrect usage, such as unlocked operations on like?
To be blunt, we have to be very blunt. We have one very, very effective way of preventing all these classes of errors. It's called garbage collection, and so we're basically we're introducing malloc-free API for byte arrays, and now we're discussing all the things that can go wrong when you allocate this way, manually, and so there's a whole class of things that are, I think it should be pretty we can sort of go through sort of exactly what can go wrong, but at the end of the day, it seems to me that that's fundamentally what we're up against here. Is it's the exact reason why these things couldn't happen is because of we were allocating these buffers from the garbage collector, which has exactly the right knowledge to know when it's safe, to actually free. And now we're saying no, we have this API which is exactly malloc in and then free just and we're gonna sort of invariably bump up against all sorts of things that could not happen if we didn't use this. If we didn't.
I'm gonna reiterate. I still believe that people can do their own pools, and whether such pool is used in our code or in their custom streams that they get from NuGet and whatnot. I don't see a fundamental difference. If you're saying that the difference is that our streams are used much more frequently and, so it will be more prevalent, then I would kind of agree, except there's this second force, which is in our streams we can get rid of bugs more probably easily than random packages on NuGet. So it may be...
There's the same thing, we have a number of facilities, people can use unsafe code, right? But they can, screw themselves a number of ways, but if they use safe code and follow the rules, they kind of can still have bugs, but they kind of give them guarantees that things won't go horribly wrong.
It's the same with so I grab a component from NuGet, which it is written in unsafe code, correct?
Yeah.
Now I'm using safe code, but the component has bugs.
Yeah, but it's your problem that you kind of, if you grab component from NuGet that has 2 stars, and then you are on your own, right?
So I agree. So it's the same with I grab a custom implementation of some stream that does wrong things with buffer pools. I grab the component that is buggy, which again I go back to me the main bar that we cannot give up literally is I use components that don't have bugs. I use .NET Framework. I don't use BufferPool. I'm the Mort user of our platform. I should not have problems, period.
Okay.
The moment you use BufferPool or use components that are buggy with buffer pools, I understand that it's getting
okay. But I think the earlier distinction was a bit more helpful because as Stephen pointed out, right, if I'm inheriting from stream and just overriding read and write, I'm not aware that as any buffer pool in the system, I'm not using buffer pool, right? But if I have this other bug that Jan pointed out, I will corrupt the system badly. I would say that if I use static functionality where I'm not extending the framework, so I would say if you derive from stream, you're more or less, for the purpose, you become part of the framework inheritance hierarchy, so you're participating in the same level. And I think that I would treat those people differently from somebody who calls file.read all the time.
Oh yeah, that's what I.
If there's a meaningful distinction we can make, we should pursue that. But I would be concerned that if we go too far, then we end up in the world that Stephen outlined, where we have 3 cases in CoreFX that we can use this, where the savings are not that high.
I don't know. If it turns out that we can only use it in 3 places, but it's safe. I think I'm fine with it. I would rather not use it in, like 100 places and then run into 3 after use bugs all the time. I mean, that is pretty bad.
I wasn't arguing that we should use it in more places just because. I was saying, like, if that's our bar, this is the consequence, which might be fine.
Well, no, I would go a step further and say, like, if it's only 3 places, like, is the cost worth it to have that component in CoreFX directly being used at all? Or should it just be a component on the side?
Well, in some places we can use it literally 100% safely. So there are some of those. We should.
Do we know how to find those and actually do it the right thing? I guess.
Whether we know how to find it? Yeah.
Whether or not we think we can safely use it.
Well, it's like we can safely use it, but I think what you will find that most of the cases are trade-offs, right? So, for example, file stream, you can safely use it in file stream, but you pay like interlock operations on each operation, right? And I think in file stream it would be like good trade-off, like some methods on file stream that shouldn't really be there, like read byte, would regress, but like I would argue that get byte on a file stream is kind of
the API in the first place.
Stupid API to start with,
Yeah. But I mean, like, I mean, at a very high level, it's simple, right? If the API doesn't expose arrays, right, like, it's intermittently safe, right? Like, that's an easy one. I think as soon as the arrays pass around, it gets more tricky.
No. It's not just that it cannot. Of course, it cannot hand the array to user code, unless it's like to user code that we said it's like we consider it unsafe, like you're doing an extension to the framework, correct? But the second thing, what it cannot do, it has to be very careful with threading. Like like in file stream, we need to make sure that we harden the dispose method with all the async operations. It's all internal, but if we in dispose return
it's like you basically need to treat the buffer pool the same way as you treat any unmatched resource, right? Presumably just use safe handle.
Yeah.
Mm-hmm. Yeah.
Or like probably safe handle is kind of not necessarily the perfect fit for it, but have like safe handle equivalent for buffer pools, for buffers from buffer pool.
So this may be a naive question, but is there any way we could basically treat these buffers as weak references, and if they basically nobody references them, then they go back to the pool automatically? Is that something we just can't do?
Well, that's basically what GC does today for you. Right, the only optimization you can sort of make there is that you can kind of save on the zero filling if you do magic in the GC, but I believe these are zero filling the buffers anyway, right? So,
well, I mean, the only difference would be if the buffer is basically large enough to be on the LOH, right? Then you would benefit a bit because you don't have the fragmentation that happens there, right? You wouldn't have to compact it, you wouldn't have to do anything with it because you would reuse these buffers. Essentially, right? But yeah, I don't know.
Another thing, but all good issues. Another thing I kind of experimented with is having a native memory span. I mean, native memory buffer, and then just using it with spans. Like basically, that was I had a native buffer pool implementation. It just allocates very large native memory, chunks it into whatever chunks it needs, hands only spans, nothing else.
I think the fundamental thing is that you've got spans, right? Like if we have spans with like the current buffer pool, like it will be much better, right?
Yeah.
So whether you kind of get the actual memory that's recycled from GC heap or not, that's just like minor point.
Which, and so that leads to what I wanted to say. So I was kind of, for some time thinking about all these issues, and I was thinking maybe we should start really, really conservative with usage. As I said, if we can convince ourselves that we are completely safe, we are using it, and it's more like a feature that anybody could implement. It's a buffer pool that could be on NuGet developed by a third party. And then once we have spans and we have native memory, maybe then we can use it in more places.
I mean, it sounds like that's where we're landing. We're basically saying, from a design perspective, technically we will only use it in CoreFX if we can 100% prove there's no chance of incorrect usage. There's no chance of a problem whatsoever. We're not handing it out to any other code. It's just on the stack, etc. Then on top of that, there's the question of, all right, well, in the cases where we can actually meet that bar, is it actually useful to do? Are the trade-offs from a performance perspective there? And that's an engineering question that whoever is doing this work would figure that out with perf testing and the like.
Let me ask you a question. You described the bar. Are you still including the caveat, if somebody else in a system uses the pool and they screw up the pool, like they return a buffer, that then we grab, and our code is 100% safe, but we grab a buffer that they still hold to.
Well,
and
if that's a criteria, we can't use the buffer period. We can't use the
yeah. Okay, so
but I think that's fine. Like basically what the buffer pool allocator is like. It's like we used to call these things like different names. Like it's basically security critical code. It's like if you use it incorrectly, like it can cause bad things to happen. Right? There was like another proposal I saw, like on, I think it was in the Roslin report, that maybe there should be like unsafe. Code has to be unsafe attribute where you mark things that, hey, like it's like it has all good safe types in signature, but it's like fundamentally unsafe API to.
I would love that, by the way. But I would agree with you. Like if the bar is, we need to protect the buffer pool, then like the game is over, right? I mean, there's no way to expose that. But I would treat buffer pool probably the same way I would treat Marshall. Like if you use this incorrectly, you will hang yourself very badly. And
so another thing we could consider, there was an option that we had on the email thread, which is, should we create our own buffer pool for framework components to isolate ourselves from user code? And that one has the disadvantage that I would, then we would like, buffer pool is already large, correct? Like if it's not used frequently, it may actually be negative net benefit. So we want to minimize the number of buffer pools, therefore.
I don't think that leads anywhere, right? It's like in Windows, they were on this plan long time for a while where they say, okay, like each component creates its own malloc so that, when one component screws up with malloc, the other guy can still run fine, right? And it just didn't work, right? Like today, there's like one global malloc free, and that's it, right?
I mean, to be fair, my biggest concern is also about the maintainability on our side, because if we would have an internal static thing somewhere, we'll suddenly have to deal with either like internal contracts or some other way to inject this thing, and then like God forbid we want to actually version these things independently again, and then we break the APIs and shit happens. And I think that if we don't believe it has any value, I wouldn't go on the complexity path. I just called it out because I mean that.
Like back to one thing about the diagnosis, but I think it would be super valuable to have a switch in the buffer pool that basically turns off the caching. So it would allow what it would allow to do if somebody has like a complex system, they bet on the buffer pool like for whatever reason, and now they are seeing weird crashes. Okay, how do they tell? Okay, is it the buffer pool or is it like one of those other 10 things, right? So having a switch that says, hey, buffer pool, crash still there,
I think it's a very good point. Yeah. We should do it.
Do we have that API today?
No.
Yeah. It needs to be kind of, configurable from the outside or something, like.
Yeah, it's basically turn off buffer pool. Yeah. Change it to be like GC.
Yeah. Mm-hmm. There we go. The first step to make it more kind of diagnosable. And
we could even make it on a kind of like per rental basis. No. Just to turn it off. Yeah. Now bugs disappeared.
You're just talking about making return a no-op, right?
Yeah. Yes. Yeah. The bugs disappear. Now you're like, okay, which component is screwing up the user?
Yeah, exactly. Right. That's kind of the next step, but then it becomes more tricky, right?
So it's like you have the hypothesis that maybe the buffer pool is the cause of the weirdness. You turn it off, and the weirdness goes away, and now you know to look for bad buffer.
Yeah, it's kind of not 100% guarantee that if you turn it off and the crash goes away, that the it's in buffer pool, but it's like strong indication where to look at, right?
Right.
At that point, maybe you then turn on the ECW events that we have, and you correlate them with your other operations, and yeah.
So we already have ECW events, by the way, for the buffers, or is it something?
Some. Can you remind us what are the events that we have?
We have
So rentals, returns. I think we have some when the pool is exhausted, we have to allocate.
Do we have a tool that could analyze the traces and discover when there's a return after rent?
Could certainly
when there's a pattern where we basically rent.
Sorry, I was going to say we could certainly update, like add to Purview to do that, and you could see the events today in Purview, but there's no analysis.
I think there's correlation IDs between rents and returns, so you can correlate a rental ID with a return ID. I believe.
What I meant is like basically when you have the threading issue, I think potentially we would return twice, or we would. I'm not sure how we would return the time.
Well, you would see.
You can do post-processing manually because with the ECW events inside code using a trace listener, because we give a unique ID per actual buffer instance, so you can actually track each buffer instance and see if it was returned twice or rented twice.
Yeah,
or see if it was rented before it was returned or whatever. Yeah.
Well, that one, yes, but the async I was hoping that we can discover the async.
The async case is basically a use after free.
Exactly.
So the diagnostics you can do for that one is to fill the thing with unique pattern on return, and when you kind of want to check it out, you verify that is that pattern still there intact.
Right.
That's kind of the classic malloc-free kind of playbook, guys.
Yeah, I wonder whether we should invest in doing more of something like this. Diagnostics is just it adds it adds cost.
But it needs to be kind of optional the same way as malloc-free diagnostic is optional, but there needs to be a way to kind of turn it on, ideally through config files, so that you can just
right, or you expose an API like set diagnostic mode, which allows it to be drop on return, fill with garbage on return, whatever, and then someone can easily hook it up to whatever they want in their own code to say like, if I set this environment variable, call this method.
Yeah.
There is no way we can protect the memory thread. That would be a nice feature.
That would require magic with GC, and it's like. It's kind of the extreme kind of case. I think if you have to go there, like, you have a bigger problem.
Really?
No, it's just the kind of what it means that the kind of the complexity we have to invest into to deal with the solution is like way more than like the kind of the problem benefit we are getting out of the solving a problem, right?
Yeah, well, it seems, I don't know. I understand that it's way more costly than just implementing, an API on top of array, but I don't know. Maybe at some point we should think.
So I think we
about something like this.
got everything out. Like, Steven, is there anything more you want to get out of that? Otherwise, we should quickly talk about the exception thing.
I think we have our answer.
All right. So Steven submitted a PR that fixed argument exception instances via using nameoff, which was, I think nobody had a problem with that part. But he also changed some exceptions to throw-derived exceptions instead. And there was a discussion on the PR 6389 that went into detail, like whether we think that's compatible, that's incompatible, whether it's worth doing, and all of that. And there was like a huge range of opinions, pretty much on both extremes in the spectrum, I would say, from we should never do this to, oh, it seems like safe, but we shouldn't do it, and to, oh, I think we should just do it. To just echo the concerns, I think one of the concerns was, well, we add little value by changing the exception types we throw.
What?
We add little value by changing the types to derived ones. People do, for better or worse, catch exceptions, and that obviously changes the behavior if you throw a different exception type.
But let me clarify. I used the wrong word. I said whether it's a compat problem. It may be compat problem. I don't care about in this case. What I'm after is portability.
Yes. So basically the idea is that when we talk about compatibility, that's the difference between I compiled against an older version of something, I run against a later version of that. So it's a V1 to V2 issue. Portability deals with two unrelated stacks where you want to make assumptions that hold true on both sides, right? So if one stack throws a derived type, the other one throws the base type, then if you catch the derived type, well, you will no longer catch it on the other side, right? Which is harder to reason about. I would generally say sorry. Yeah.
But you can, like, once you know that problem, you can go fix it, right?
Yes. So I would say,
assuming in this case you could, because there's a hierarchy going on. In some cases, it might not be true if you throw a completely different exception that's in a different hierarchy.
Well, you can always catch the base exception type. Yes, you can go very.
You can catch this or that, right? It's like
fuzzy, but.
Well, I would generally say that's also an incompatible change at that point, because then it's a D1 to B2 issue too. Like, I think, but I mean, if you throw a derived one, that's generally considered compatible, but it has the portability issue, right? Yeah. So I think we should generally optimize for making it damn easy for people to just write code the naive way, and it happens to be portable. So, like, they shouldn't have to figure this out in the perfect world. But I also think for things like argument exceptions, if you write catch enters for that, I would also say, well, this is not something we should be in the business of optimizing for, because you're really doing the wrong thing. Like, you shouldn't catch any of those. And if you really go down that path, then I would say then you're probably also not afraid to write catch exception, right? I mean, like,
it's clearly documented that we don't want you catching argument exceptions.
Okay, so actually, you know what? If we wanted to have the following stance, if it's one of those exceptions that you shouldn't be catching, like for usage errors. Yeah. My position is that it almost like the exception type doesn't matter. The most important thing is that you have diagnostic information, you have good error message, and so on and so on. At that point, I'm like, I don't care what exception type we throw. I would still want the guidance that I pushed for in this PR for the runtime errors. Like, if there's an exception that we actually say, file not found exception you should be catching, I would not want to do what the PR originally was doing, which is throwing a exception that is more derived than some other platform. And because .NET Core, we already have lots of cases where that's already not the case, because we have different exception types that we throw between .NET Framework and .NET Core. And what I wanted to say is, in the direction of .NET Core throws the more base, less derived exception, I think that's fine. And the reason for it is that I think, and that may be arbitrary, .NET Core should be the gold standard. Like, if I want to write portable code, I think people should write to .NET Core, and they will be like, they will write code and they will get some exception, and the exception is thrown and it's, file not found exception. They will be, okay, let me catch file not found. And this code should work on .NET Framework.
Does not apply that every bug we fix in Core absolutely must be fixed in .NET Framework?
Yeah.
I mean, I don't know if I don't know whether I would say as black and white. I just say, there's a steady state line. We should kind of keep trying to get the code base to the steady state line. Like, there's a gold standard .NET Core. I write code to it. Yes, of course, some things will not work on .NET Framework, but we shouldn't make it worse unless we have a very strong reason.
I feel like this isn't even close to like the worst thing that you'd have to deal with, like in terms of like things that are not guaranteed by compilation. Like, so we've always kind of taken this like wishy-washy stance really with portability. Like, exceptions are interesting because they're like, they could be in the signature, but they're not. But generally speaking, like, all of the sort of rules that we have, all the infrastructure, the way that reference assemblies are defined, the entire framework for doing portability is based on like, mostly if you compile it works, but then you still got to run and test your code. Like,
correct.
And we don't guarantee. And we don't have the means to statically guarantee, that because you have the potential to run, there won't be bugs. And we do just plain fix bugs sometimes and say, well, yeah, but if you go and run this code on a framework that doesn't have the bug fix, well, you're still going to hit the bug. And so, there's a spectrum here. Like, I feel like that basically this applies basically to all the non-breaking changes in that document, where like one of the first ones is like throwing a derived exception is okay. So I've historically taken the model in my head is we can make behavioral non-breaking changes, as we've always sort of said we could make from one version to another of a platform. We can make them in .NET Core and not necessarily fix them. We don't even have, with the different release cadence, we can't fix all the bugs altogether, nor can we make any guarantees about that because not everyone will have deployed all the debug fixes. So I see this as like, if it's a not behavioral change that moves in the direction of fixing a bug that's deemed a non-breaking change, yes, there can be sort of edge case portability issues. But I don't think that we should further restrict that set, which already is a small set of things we're allowed to do, based on this sort of, well, there might be observable differences for a portable library. I think we should accept that that's the case, and the way that you deal with those is you test your code at where you want to run, and sometimes there are corner cases, but I feel like they should be corner cases if we did a good enough job describing what are the sort of behavioral changes you're allowed to make.
But Nick, so I would agree with you. You mentioned fixing bugs. I agree with you for fixing bugs. I really do. Correct? Like we should be fixing bugs, and if it results in portability issues that can be mitigated, meaning like yeah, by default, if I wrote some code, it's not portable, but then I can change to something and now it's portable. I'm all for it. The reason I reacted to this PR a bit is just it also is a combination that I didn't see a lot of value. I like throwing a argument exception, not argument null exception. I don't consider it a bug. I mean, like it's an aesthetics issue. So
that wasn't the bug. The bug was that it's the parameters were completely wrong.
Yeah. Oh no. That one I thought we checked in, correct? Because
that's all of the ones that changed to derived types. We did so because the wrong arguments were being passed. To fix it, we would have had to add resources so we could provide a message. And instead, we could just throw the derived type, which already has a built-in message.
Okay, you're saying because of now the cost of not doing this, you didn't fix. Yeah, but let me like. Okay, you're basically saying because of the cost, now you didn't do the.
So I'm saying we weren't, and to be clear, I was resubmitting somebody else's fix, so I'm not taking credit for the fix. But we were doing this to fix a bug.
Yeah, it's the right fix, right? Okay, if we didn't have, if there was a bug, and this is the best fix, I think that's the best fix. You can argue it's limit in value, but if the code had been written correctly, it would. The very fact that it just wants to pass a parameter name is indicative of the intent that I don't have any. It's null, whatever.
So let's discuss a bit of guidance and theoretical issue, not the specific one. What I wanted to say is, let's say the bug was the issue somebody filed was, it's throwing argument exception and it should be throwing argument null exception. There are no issues with messages or anything. It's just changed return type. I mean, exception type. I would say the value of this change is so small that the negative impact on portability, I feel like, is more important. For the exceptions that people should be catching. For the usage exceptions, as I said, I kind of don't care. It's exception message is the most important thing.
Well, but to be clear, this PR, there are no exceptions changed. There were not.
Yeah. Therefore, now that we now that somebody pointed it out, I agree.
So you're fine with adding the original bug fixes?
Yeah, I'm fine with this one, and in general, I'm fine with the guidance that says that basically, if it's a usage error and it's in a compatible change. We don't care about portability of those because you shouldn't be catching that.
Yes.
Great.
The other thing I would say though is for portability, the one stance we've also taken in the past, which was less of less of an argument from construction, more of an argument from reality, is that we said we cannot make everything portable considering the world we live in. We have to sometimes evolve an API that by contract said this API will always work, and relax the rules to say this API may work. So we basically said, well, if we have these cases, then we give you new APIs that will indicate to you whether the operation is supported and you're expected to call this. So essentially, we are weakening our guarantees in order to optimize for reach. And so we said, well, from our point of view, we cannot build a system where you can write code that will be portable by construction in all cases. There will be cases where you will, after the fact, have to go back to your component and be aware of the fact that you may run in a context that doesn't support X or Y. And we said our bar is we want to design APIs and evolve our existing APIs to make it so that you can write portable code. And sometimes that means you have to change your code and take into consideration that things that used to always work now may fail in various ways. And I would see changing the exception types are more or less in the same spirit, because sometimes we may add new exception types to that you also have to handle. Sometimes we may not. And I think I get your point of we shouldn't arbitrarily make changes for cosmetics, which I buy, but I think we should also be very careful that we don't claim that we, try to get something that is completely unrealistic.
No. I already said that portability, I write code to the gold standard. I should test it on all platforms.
Yes.
But there should be the least number of landmines that we put in the system. Therefore, if it's an exception that is something that people should be catching, I think the default should be, I would prefer the gold standard to throw the exception that is the common denominator exception.
There are some
with departure from this rule in some cases, I think it's also fine. It's just as a rule of thumb, I think it's a good rule.
So we agree we're going to put back the fix as
correct, because they are usage. I would say the main reason is they are usage exceptions. Okay, well, they shouldn't be nobody should be able to handle them. Therefore, the issue of portability for exception handler is non-issue.
Okay, and now another case where this has come up in the past is there have been some bad APIs implementations that threw either argument exception, but you had to catch it, or through exception and you had to catch it, or application, something so generic and yet you had to catch it. And in the past, between .NET Framework versions, we have actually fixed those as in order to allow the competent, sort of mindful developer to catch something more reasonable than the. Would we consider those changes in .NET Core? Considering that we've even made them between .NET Framework versions, I would want to say yes. I think we shouldn't just change exception types because we can, but I think the clause that says that we can is useful in some specific scenarios. One of them is we screwed up. We threw this exception. It's you're not supposed to catch that. It's so generic that it's useless. We should at least throw something meaningful. I think we should still be allowed to do that also. But
are you saying is the example that you gave? Is there a difference between frameworks in what exceptions they throw?
Versions, yes, we have done that in the past.
No, not versions. Between let's call them Redis or platforms.
I would guess that almost certainly there are, but I don't know. I don't have the data. I had the link that I point to actually gave an example where we made a derived culture not found instead of just saying argument exception, because you can't know if the culture is going to be found. So you shouldn't catch argument exception, which is what you had to do in .NET 3 or 5 or something, and then in 4.0 we fixed it. But there are even worse examples. There are places in the bloody framework that throw exception, the base class.
No, but if I understand correctly, you're talking about just changes, whether they are comparable or not. I completely agree. Changing to a subtype is a comparable change. We should be doing those. The thing that previously we discussed, the portability issue, to me, it's the .NET Core should not be leading for
derived type.
Derived type. And
as long as you can write portable code, I don't think it matters. One side or the other side. If we think we're doing the right thing, we should just do it.
Yeah.
And if there's a value, now you're describing cases that the value is so much higher because we now throw very generic exception and there's no good way to handle it without some complicated filters and possibly running code. Yeah, the value is high. Should.
Well, the other thing we did it by design is actually com interrupt, or winner T interrupt in particular. So we say instead of throwing com exception, we throw exception that sets the error code. So that if a new error code shows up, we can project it to basically a different exception at some point. Which case, the error message you get probably is pretty shitty. I mean, whatever like Windows provides, given the error code lookup mechanism, that it's the error message that the exception will have. But you don't have to catch exception and ask for the error code. In the future version, you may be able to say catch, found not found exception or whatever the code is that we add. And I think that's generally good. I would also say, as Nick tried to hint, is that if we consider something compatible between framework versions, that should be good enough for portability too. Because I mean, like that is the most conservative compat bar that we have, and it is one of the biggest problems we have.
I agree. Except look at the portability between versions. If you want portability between versions, you probably want to write your code to the previous version and hope that it will run on the new one, not the other way. When we lead in .NET Core with exceptions more derived, we are kind of in the situation we're telling people, if you want to write portable code, write it to the newer version, kind of the newer version, and then so it's
it's hard to say what's newer and different when they have different cadences, but I think here's the summary. It's like all of those behavioral changes that we tolerate that can cause problems in portability that we tolerate, they all have this one caveat, which is like we don't do this just cause, right? So here we have a case like the exception messages were wrong, so now one of the tools at our disposal is among these behavioral changes. So I think all these behavioral changes should be like, I don't think we should have. It's not going to work to have a set of things you can do between versions, but you can't do them in .NET Core. It's too hard. Like these are behavioral changes are like, it's basically you can't, like, this is a list of things that are yes, you can come up with ways that it doesn't work, but fundamentally they are maneuvers at your disposal. But they all come with the basic thing that says they all carry some risk of these portability problems or like really bad code taking a dependency on them. And so we don't just do them. Like but when something comes up, there's a bug, there's an exception that's really, really too general, there's some impetus to do it, then these are the maneuvers that you're allowed to do. I think that's easier to reason about than to sort of like to say make special rules about usage exceptions, or like, I don't know. I think it's like
I tend to agree with you. Basically, we shouldn't sacrifice portability if there's not a lot of value for the change. And when I saw the PR, I didn't initially I didn't take into consideration the resources thing that you guys mentioned. I just saw a change from argument exception to argument null exception. Yeah. To me, the value of doing the value of this is close to zero, and I'm like, for a value of close to zero, we are making portability a bit more complicated. That's why but if I agree. If there is a value, if you're fixing a bug, if you're improving the way that now we throw very generic exception and that you literally cannot handle in a reasonable way. If there is value, yes, we should be able to do those.
So summary is we don't have to change our guidance. The guidance that we have right now, which is throwing a more derived type, is compatible, is fine in the guidance, because as Nick pointed out, everything we do is more or less case by case. I mean, we review every change, and sometimes even compatible changes we don't think are worth it, right? I mean, so that I think that I would just leave it as that.
We call those out like they're compatible because we define them as compatible, but like someone else's definition of compatible could make them incompatible, right? So that's why we don't just do them, right? It's not like
I would add a note that because basically the guidance that we have today is all about compatibility. I would say some of these changes also have impact on portability.
They all
and the value should be should be proportional to the cost.
I argue that every one of those quote-unquote behavioral changes, acceptable behavioral changes, have portability consequences. Because they're generally there to make things better in some way, like to fix a problem that was in a previous version and to give you outs to fix those problems. And if you fix problems in one version, but you want to run on the version without the fix, you're going to have exactly the portability problem.
Yeah, I mean, like a very simple example, right? Adding an API we consider a compatible change. Well, does it have portability issues? Yes, because you cannot port to things that doesn't have the API.
That one is handled by the system, though, by the compilers and the reference assemblies, though.
Well, to a degree, right? I mean, like my point is that I think there's a difference. It's a different dimensions, right? There's portability and then there's compatibility, right? And I mean, for .NET Core, we try to do both, right? We try to say this is the foundation for future SKUs that are basically composed of .NET Core. We want to be compatible with within that ecosystem, or sorry, portable within that ecosystem. But we also take care about portability and compatibility between .NET Core and full framework, right? And that is, I think, a dance that is case by case, because we can't just take the standard and say we will be compatible in all cases, because we just can't, just based on timeline. But we also shouldn't make arbitrary changes, which is why I think. I don't think there's much we can do for the guidance, but I mean, feel free to submit a PR and change the wording in the way you see fit. But I think the way the document is written right now is, I think the headline is, as Nick just said, acceptable behavioral changes. And I mean, to me it is acceptable, but maybe worthwhile to qualify that.
All right, I'm fine.
So we revert the revert, right?
Yep. Revert the revert. Great line. All right, then thanks guys online, and then see you later.
All right.
Thank you.